What's up, Calc gang? Welcome back to some dynamics. So we got a disk. I didn't draw the image, but we have a disk. It's driven by a motor, and we can tell that its degree, right, its angle, is going to be 20t plus 4t squared radians. So it's going to spin, and it's basically how many degrees it's spin, or how many radians it's spun, is given by this equation relative to time. So our goal is to find the number of revolutions, the angular velocity, and the angular acceleration at t is equal to 90 seconds. So let's go ahead and solve this problem. So right, what is this theta, what is this equation telling us? Well, this is telling us that at any time, if we plug in t, we're going to find out how many times we've rotated in radians. And so first of all, we're trying to find the number of revolutions. So let's try to find out how many radians we've spun at 90 seconds. So to do that, we're going to plug in 90 for t. So we're going to do theta of 90. And of course, this is going to be equal to 20 times 90 plus 490 squared. And so you get theta of 90 is equal to 34,200 radians. Okay, so we want it in number of revolutions. So right, a full circle, right, if we were to complete a full circle, this is 2 pi radians, and it's 1 revolution. So to convert from radians, we're going to take that 34,200, and we're going to multiply, or actually we're going to divide this number by 2 pi, right, because it's 1 revolution per 2 pi radians. And so this is going to leave you with theta of 90 is equal to 5,443 revolutions. All right, so now let's find angular velocity. So similarly to how velocity is the derivative of location, what is that? Displacement, right? Angular velocity is the derivative of the angle, you know? What do I say? The number of revolutions, right? The degree. The angular distance, whatever you call it, right? So we're going to take the derivative of this, d dt. I'm going to take the derivative of theta. So it's going to be, our equation is 20t plus 4t squared. Right, so the derivative of this is equal to the angular acceleration. And if you take it, you get 20 plus 8t. All right, so now we're going to plug in 90 seconds. So w of 90 is equal to 20 plus 8 times 90. You get that w of 90 is equal to 740 radians per second. All right, so then take a wild guess about what we're going to do for that angular acceleration. We're going to take the derivative again of angular velocity. So d dt of angular velocity, which is just 20 plus 8t, that's just equal to 8. So very simply, our angular acceleration is going to be 8 radians per second squared, and it's constant. And so there we go, that's the problem. So a very easy problem, right? Just about taking those derivatives, but hopefully we can get into some more complicated problems next. So thanks for watching, and I'll see you in the next video. Peace.